All right, so the last part of this unit is talking about geometric series. So the sum of a geometric series is here. You use this equation to find of a finite geometric series. So a sub 1, the first term, times 1 minus the common ratio to the nth power divided by 1 minus n. So we're going to do an example here. So we're going to find this is finite because it stops, and we're going to find the sum of this finite geometric series. So the first thing you want to do is you want to figure out what your common ratio is. So to find R, you're going to take 90, the second term, divided by the first term. And notice that 9 goes into both those terms, but actually 18 goes into 90, so that's 5. Okay, and if you carry through and do the division on all of these, so I'll just show you the last one. If we take the last term and divide it by the second to the last term, you're going to get 5. So this is a geometric sequence, because our sequence right now, but in order to find the sum of the series, if we had pluses there, so I should probably have pluses there, we're going to use the equation up here. Okay? So what that means is to find the sum to the 1, 2, 3, 4, 5, there's 5 terms, to the fifth term, we're going to take the first term, which is 18, times 1 minus the common ratio, so we said that was 5, and the number of terms we said was also 5. Probably ought to write that down, so n equals 5. And then we're going to divide that by 1 minus 5. Okay, so when you do these in your calculator, you really need to be careful on these, and make sure that you're following order of operations. So that is, especially with the denominator there, make sure that you're taking 1 minus 5 first and then dividing by that, or put parentheses around that difference. Anyway, when you calculate what that value is, you would get 14,058. Okay, now notice, because this only has 5 terms, it might be easier just to add the terms, but you can always verify that when you add all of these terms, you get 14,058. All right, so now we're going to talk about divergence and convergence. So divergence and convergence. So what divergence means is that it goes away. It doesn't, when something diverges, it doesn't come together. It spreads out. When it converges, that means it gets closer together. Okay? And in mathematics, we say that this approaches a limit because it's always getting closer and closer and closer to some number, or it has a sum. Okay, now if you're looking at the value of the common ratio, then when something converges, that means it has a sum. Your common ratio, or the absolute value of that common ratio, is less than 1. Now when something diverges, or a series diverges, that means it doesn't have a sum. So if a series diverges, there's no sum, and it doesn't approach a limit. So in this case, your common ratio, the absolute value of that is greater than or equal to 1. So let's look at these two examples. The first one, or both of them say, determine whether each infinite series converges or diverges. So let's look at the first one. So first you need to decide what is that common ratio. So in order to do that, this one is one where you can use your intuition without doing any division. If you take 1, what do you have to multiply that by to get 1/5? And then in turn, what do you have to multiply that by to get 1/25? So in this case, r is equal to 1/5. Okay, since that number is greater than 1, that means that this this series diverges. What am I saying? That's not true. Sorry, I made this wrong. Let me go back and fix this. Okay, sorry. Okay, so this actually is less than 1. I'm not sure what I was thinking. So what that means is it converges. And in the second case, if you look at the common ratio, so what you're doing is multiplying by 2 to get the next value. So because that is greater than 1, then this series diverges. Okay, and then your homework's going to say, does it have a sum or not? This will have no sum, and then this one has a sum. So let's see if we can figure out what those sums are. So to find the sum of an infinite geometric series, okay, and it's only infinite if your common ratio is less than 1, you use this equation. So you take the first term divided by the difference between 1 and your common ratio. So for A, to get from 1 to 1/2, you're going to multiply by 1/2. To get from 1/2 to 1/4, you multiply by 1/4. So to get from 1/4 to 1/8, you multiply by 1/2. I'm sorry. So you multiply by 1/2. So your common ratio is 1/2. And that is less than 1, so this one's going to have a sum. So to find that sum, you use that equation. The first term in this series is 1, and then the common ratio is 1/2. So if you look at that denominator, 1 minus 1/2 is 1/2, and if you divide those values, so copy dot flip, you're going to get 2. Okay, so the sum of this series is 2. For the second example, this one's in summation notation. So this value, the r, the negative 1/3, let me change colors, negative 1/3 is your common ratio. Okay, because it's the one that's raised to the n minus 1 value. If you go back and look at the very first day when we talked about a geometric sequence formula, that this is this equation. A sub n is equal to the first term times r to the n minus 1. If you look at that and then you compare it to this, you're going to see that r is negative 1/3, and the first term is going to be 1, right? So because the absolute value of r is less than 1, that means this is going to have a sum. So let's see if we can figure it out. So we're going to use the same equation. S is equal to the first term, we've already determined that's 1, divided by 1 minus negative 1/3. Okay, so if the 1's going to stay in the numerator, and if you divide that by 1 minus negative 1/3, notice there's 2 minuses there, so it's 1 plus 1/3, which is equal to 1 over 4/3. you copy dot flip that, and you're going to end up with a sum of 3/4. All right, so that ends today's